let us look at some examples on the relationship between the mole and relative atomic mass and relative molecular mass. Let's take a look at the first example here. We have the question that says, calculate the number of moles present in 10 grams of calcium trioxocarbonate 4. Calculate the number of moles present in 10 grams of calcium trioxocarbonate 4. Of course, we know that calcium trioxocarbonate 4 is a compound that is made up of calcium, carbon, and oxygen. So calcium here has number of atoms as 1, carbon number of atoms 1, while oxygen 3 as a number of atoms. So the first thing we'll do in solving this question is to look for the molecular formula of calcium trioxocarbonate 4. Then we'll now go further to calculate the relative molecular mass of the compound. So here we have molecular formula as CaCO3. So that is the molecular formula of calcium trioxocarbonate 4. Next thing we'll do is to look for the relative molecular mass. Relative molecular mass. Okay. Of course, this will give us 1 multiplied by 40 plus 1 multiplied by 12 plus 3 multiplied by 16. All these together will give us 100 grams. So that is the relative molecular mass of calcium trioxocarbonate 4. So having calculated that, we can now look for the number of moles that is present in 10 grams. Of course, we know that the relative molecular mass from our discussion on the relationship between mole and relative molecular mass, we say 1 mole of a substance is equal to the relative molecular mass. So we can simply say 1 mole of CaCO3 is equal to 100 grams. Okay, 1 mole is equal to 100 grams. So 1 mole of a compound is equal to the relative molecular mass of the compound, as we have here in calcium trioxocarbonate 4. So if 100 grams is equal to 1 mole, the question is how many moles will be in 10 grams? So we can simply say 100 grams of CaCO3 is equal to 1 mole. Okay, therefore 10 grams of CaCO3 will be equal to 10 multiplied by 1 divided by 100. Of course, this gives us 0.10 mole. So this is the number of moles present in 10 grams of calcium trioxocarbonate 4. It is very easy. Now let's look at the second question here. It says, calculate the mass of 3 moles of oxygen gas. Calculate the mass of 3 moles of oxygen gas. Okay, so now let's look at the solution to the question. Now, 1 mole of oxygen gas, of course, is equal to 32 grams. Now, oxygen gas has an atomic mass of 16, as we have here in the question. So we have 1 mole of oxygen gas, 1 mole of oxygen gas written as O2 is equal to 2 multiplied by 16, which is equal to 32 grams. So 1 mole of oxygen gas is equal to 32 grams. So we can now find the mass of 3 moles. So if 1 mole is equal to 32 grams, therefore 3 moles of oxygen gas, 3 moles of oxygen gas is equal to 3 times 32 grams. This will give us 96 grams. So this is the mass of 3 moles of oxygen gas. If we have other gases, also other diatomic gases like nitrogen, if you are asked to find the mass of the number of moles present, you simply find the mass of 1 mole, which is multiplying the atomic mass of the element by the number of atoms, and you can now go further to look for the mass of the required moles that is given in the question. That is how simple it is to calculate the mass of the number of moles present in a molecule or a compound. With this, we'll come to the end of this class. Hope to see you in our next class, where we're going to be looking at the relationship between the mole and the Avogadro's number, where we are going to look at some calculations on how you can relate the mole and Avogadro's number.